Right, in this short tutorial I'm going to go through the rules of logs with you. And the reason for going through this is because logarithms are the basis of the decibel scale. So, logs to the base 10 are normally written in that format. Sometimes you will see it written simply as a log. For all the aspects that we're covering on this course, we are simply going to be referring to the log function as log. Now, logs basically is a way of reducing the scale of measurement. So in terms of log to the base 10, we count according to factors of 10. So we start off with 1, 10, 100, 1,000, 10,000 and so on. So each time we're going up by a factor of 10. A couple of useful rules to remember is that the log to the base 10 of 10 is simply 1. Simply that means that there's only one 10 in 10. Log to the base 10 of 100 is actually the same as log of 10 squared, because 10 squared is 10 times 10, gives you 100, and that has a value of 2. Log of 1,000 is log of 10 to the power 3, and that's represented by the number 3. So you can see that as you go from 10 to 100 to 1,000, the numerical values are 1, 2 and 3. Obviously the value of log to the 10,000 is going to be 4. So effectively what you are doing are converting these real numbers into something that's more manageable. The 1, the 2 and the 3. Alright, so you're reducing the scale of measurements. So that's why we use this particular scale as a decibel scale. Right, okay, we're going to move on to the rules of logs now. So this will be the next section. So to start off with, one basic rule is what the log of 1 is. The log of 1 is always going to be 0. Now that's an important rule to remember throughout the course. The other rules are really to do with the manipulation of logs. The first is when we've got a log of a fraction, a divided by b. So you might have two terms, two separate terms, two variables. We can split this into the log of a minus the log of b. We see the use of this rule quite often in acoustics. The other rule that's very useful is the log of a times b, where you've got the product of two variables. And for this particular case, this splits into log of a plus the log of b. Another important rule is when we have the log of a to the power x. When we have this particular function, we can resolve this into x times the log of a. And finally, we need to know that this particular term here, 10 to the power x, is actually an antilog. And when we do some worked examples in a while, we'll see that the antilog is another important function. So that concludes the rules of logs at this particular stage.